Hi everyone, my name is Israel Diadio from Nigeria. I'm an AI engineer with about 10 years of experience in industry and research. And today I will be doing a recap on Autograd and also on building computational graphs. And I hope that we're going to be having a good time learning together. As a way of recap, we know that Autograd across different Python frameworks like Pytorch, JAX, or TensorFlow uses what we call automatic digressation. And in Pytorch specifically, that engine that does this is Autograd. And when it performs a forward pass with Tensor, it has to use the keyword require grade to be true. And PyTorch records every operation that you do. It builds a computational graph, even in the background. And afterwards, if you call what we call a backward function, PyTorch will traverses that graph in reverse and compute the gradients. Why is this important? Is because one, it's, doing them by hand is error prone and is very tedious. That is why, the idea of autograde is one of the backbone of how we train our neural networks using PyTorch. A few things to remember when working with autograde. One is that the graph is dynamic. PyTorch will build it each time you run the forward pass. And of course, the forward propagation, which is the second thing to take note, defines the graph, and backward propagation, fills in the grade attribute on the leaf tensor. So quickly, we walk through the coding exercise 2.1, which is on building computational graph. So this expects two major input parameter, which is our W and B. Our W is our weight and our B is our bias. Our Y is the prediction we are making using the tan H, and of course, we are using a matrix called R square, metrics for this particular task. So let's run through this code together to explain how to create a simple computational graph. So we created a class called simple graph, and we defined the class constructor to mirror the class, and we're passing two parameters, which is W and B. W is the weight, while B is the bias. So here we can see the weight is expected to be a float, and the B, which is the bias, is also expected to initially be a float. And here we converted each of them into a tensor, and the carrier grade means that we want PyTorch to be able to track the operations for our weight, W and B. Also within the class, we created a function method called forward, and is expecting X, which is the feature that this function expects to be able to do the forward fill thing, like we mentioned when we were talking about autograde the other time. And of course, the prediction is taking note of our touch that is PyTorch and tan X, H rather, and X. How to calculate that is X, what is the feature inputted times whatever our weight inputted before now is, and our bias, then it returns the prediction. So our square loss is calculating, which is used, loss function is used to understand how the model is doing by our Y true parameter and our Y prediction parameter. Our Y true is the correct value and Y prediction is the predicted value. Our Y true is a tensor, which is one-dimensional tensor of a target label, and our Y prediction is also one-dimensional tensor of our prediction. And from here, we created a variable called loss, which is to do the calculation. It takes the Y true minus whatever the Y prediction is, raised to power 2, then it returns the loss. From here, we are passing what the value of the feature should be. The feature is input tensor 1. The target is touch.tensor 7. It converts that. Then the simple graph, which is now the object, we are calling the name of the class simple graph, and we're passing the two values. 0 minus 0.5 is our width, YB, which is a bias, 0.5. So here it prints the initial weight, then also prints the initial bias. The prediction, also from the simple underscore graph, it takes the forward and pass in the feature there to calculate the prediction, while the square loss takes the SQ underscore loss, which is the name of the method. It takes parameters like target and prediction. And finally, it prints for X using the placeholder format method, feature.item to get the value of X, and Y target.item to get the value of Y that will be placed on this placeholder, and prediction.item, and L2 loss, the square loss.item to get the L2 loss of this particular tax. So this way we are able to build a computational graph. Thanks so much for watching. See you again in the next class.